Okay, this is the continuation of section P2, so P2.2. And in the very first protein lecture, we kind of introduced the idea of essential amino acids, and that you require essential amino acids to synthesize proteins in your body, and that they must be provided in the diet. And so what we kind of want to look at today, or in this lecture, is the concept of first limiting amino acid. And so when going back to our trains or the Lego example, when we're trying to build something, if I only have so many tires or so many wheels, I can only synthesize so many cars. So like if every car requires a windshield and 2 doors and 4 wheels, if I only have 8 doors, I can only synthesize or make 4 cars. If I have 7 doors, I can only make 3 cars. Okay? And so the first limiting amino acid equals the amino acid that the diet supplies the lowest proportion of the requirement. It limits performance. Okay, and there are essential amino acids. There is no first limiting amino acid for the non-essential amino acids because the body can synthesize them. So again, going back to the car example, if we say a car requires 4 wheels, 1 windshield, and 2 doors, because we only make sports cars. And I give you 16 wheels, 5 windshields, and 10 doors. Based on this, if I take 16 divided by 4, I can produce 4 cars with my wheels I have available. I can produce 5 cars with the windshields I have available, and 5 cars with the doors I have available. So in this case, my limiting component, or my first limiting amino acid, would be wheels, because I can only synthesize 4 cars. Okay? These excess windshields and doors aren't going to be used for anything. In the body, excess amino acids are going to be catabolized as a source of energy. They're going to be used for other things, or the synthesis of non-essential amino acids. If I have the option, I can go in and say buy. I can talk my mom and dad into taking me to Target, and I can buy 4 more wheels and a little supplement wheel pack of Legos. And if I buy 4 more wheels, I now have 20. And I can synthesize 5 cars. So I've addressed my limiting amino acid by going to Target and purchasing more wheels. Okay? An ideal protein contains the optimal balance or ratio, if you want to use ratio, of all essential amino acids. Required for maintenance production. Of a clearly defined product. Okay, and so say we had a protein, kind of go back up here and say we have 16 to 5 to 10. We're only able to synthesize 4 cars here. Here we're able to synthesize 5. So this 20 to 5 to 10 is the ideal protein for making cars. That is the perfect protein for making cars. This one is less valuable. So if I could go to a store and pick a protein and they were the same price, I would buy this one because it allows me to make more cars, and I'm trying to make cars. Okay? So an ideal protein contains the optimal balance or ratio of all the essential amino acids required for maintenance and production of a clearly defined product. And so in our case, generally when we're talking about clearly defined products, we're talking about animal products being muscle and milk that we're going to consume. And so if you remember back to that paper we read at the very beginning in class with the children, what we really want to do is we supply proteins that are ideal in their capacity to meet protein requirements for children and humans. Okay, they provide a really ideal ratio or the optimal ratio for meeting human protein requirements. Okay, the ideal protein is determined by the product being produced. So we'll have different ideal proteins or ideal proteins in the diet if we're producing milk versus if we're producing pork or if we're producing turkey or chicken. Okay? The diet fed, so how much production the diet will support. And last but not least, the efficiency of amino acid deposition in the product. Not 100% of the amino acids are actually going to get deposited in the product. They're going to be used for some other purposes as well. So we have to understand the efficiency of doing that. How do we kind of measure or understand ideal proteins or determine protein requirements? We measure it by doing nitrogen balance study. Sometimes referred to as nitrogen retention. Okay, and the reason we're doing nitrogen balance or nitrogen retention is amino acids contain nitrogen, and if we're creating a product out of amino acids, that nitrogen will be retained by the animal in the product. It can be retained in muscle, it could be retained in milk. And so what we do is we look at how much nitrogen we feed them, nitrogen intake minus nitrogen excretion. Okay, and nitrogen is really excreted in 3 ways: feces, urine, and through the skin. We generally don't worry about the skin because that's a relatively small loss. The times we might worry about the skin would be like if we're producing wool, because a significant amount of nitrogen is produced or deposited in wool. One really wouldn't look at that as a loss because the goal is to produce wool. Okay, so we look at nitrogen balance because amino acids contain nitrogen. The better job we're doing of meeting the amino acid requirements of the animal, the more nitrogen we're going to be retaining because more amino acids are going to be deposited in the product. What this looks like is an XY. Line graph. And so we look at nitrogen retention, or nitrogen balance, is the response we're measuring. And what we have over here on the x-axis is the level of the essential amino acid. And so sometimes we would pick one in particular, and so we're going to pick lysine. If I pick lysine, what I want to do is feed a level well below the requirement, and so for this example, we'll say I feed no lysine. I create a diet that has no lysine in it, and so my nitrogen retention is going to be negative because my animal is going to mobilize tissue, it's going to mobilize muscle in order to get lysine out of that muscle to meet its maintenance requirements. And so something that's really important to understand is animals meet their maintenance requirements first. And basically what they're doing is they're mobilizing themselves to make sure they have the lysine they need for essential functions to stay alive. So they're not actually even really maintaining themselves because they're going to lose weight. If you're mobilizing muscle, you're losing weight. If I provide my animal with lysine above 0, I'm going to expect to see an improvement in how my animal is performing. And so I will see an increase in nitrogen retention. Now my animal's depositing product, so product is being deposited in the animal because I've provided lysine to it. If I provide a little more, I see a little more of an increase. If I provide a little more, I still see an increase, but my increase is decreasing. That's the diminishing returns. And then if I provide even more, I see no real increase. And this shape is quadratic. And so what we do is we draw or fit a quadratic line to it. Okay, and we can come in here and say the point where this is maximized is the requirement. Okay, that is where our animal has a requirement for lysine. If we knew what level this was, say it was 5, we could say we need to feed 5. 5 is our requirement for lysine. What we often do is feed a little below the requirement because you can see the performance gain is relatively small. So we might feed at that point down here, and that would be much more of an optimization. We're not trying to maximize performance, we're trying to optimize the cost of providing the amino acid against the performance gains we're getting. So we're optimizing performance. I want to name this line so you guys know that it is a quadratic. Okay, and so this is basically when we provide essential amino acids in increasing levels, we're going to see a response that looks like this. Okay, to do a requirement trial, there's kind of 3 rules. And those 3 rules are 1, the basal diet, and so that's just the diet that we're feeding down here at 0. It's the diet without any added amino acid. The basal diet must be deficient in the nutrient. Okay, and so this is like anytime you do a nutrient requirement study, your basal diet, the diet at 0, must be deficient in the nutrient you're trying to study. If it's not deficient in the nutrient you're trying to study, there's no point in doing the project because the line will be flat. Because if we've already met the requirement, nothing's going to happen by adding more. You're basically operating in this realm up here where you've met the requirement. The other thing, or another thing we must have, is the basal diet must contain adequate levels of the other nutrients. We'll talk about this concept in a second, but say my animal's short in histidine, which is also an essential amino acid. If the animal's deficient in histidine, like we're feeding no histidine, then no matter how much lysine I add, I'm not going to get an improvement in performance because histidine becomes my limiting amino acid. Okay, and we'll talk about that a little bit more in a second, why you must provide all of them at the same time. And then the other thing you need to do is you must have greater than or equal to 4 levels of the test nutrient. Okay, and at least one of those one in excess of expected requirement. At least one of them must be in excess of the expected requirement, so you can make sure that you get a quadratic line, or you can see where the actual requirement is. This one has to be above the requirement, so you know where the requirement actually lies. Okay, this is going to seem random, so we're not going to do it. Okay, go to another page. And so sometimes you'll see this concept illustrated as a barrel. I use a dam because I like dams better than barrel. And when I was little, I used to not be able to say the word dam. And we would go drive by this dam, and the name, they had a store by the dam, and the name of the store was the Dam Store. And so whenever we would drive by this store, I would ask Dad if we could stop at the Dam Store, just because it was an excuse to say the word dam. So we will draw the valley that we're going to dam up. And basically, the deeper the valley, the greater potential I have to store water. And so the deeper the valley, the greater potential I have for growth in an animal would be kind of to extend this, right? So if I have a lot of potential for growth, I need to provide a lot of amino acids. If I have a small potential for growth, I need to provide fewer amino acids just because I don't have as much potential. Okay, what we want here is only essential amino acids. That one's really wide, but we'll figure it. So the others will be narrower. Okay, so we have 4 amino acids. We have valine, threonine, methionine, and lysine. Okay, and when we look at this dam, we can see that our construction's shoddy because it's real crooked. Okay, and when we look at this, we say, what is our first limiting amino acid? What amino acid is preventing us from maximizing water storage? And the answer is lysine is our first limiting amino acid. It is the lowest. Okay, if we could go to the store, we would go to the store and we could buy additional lysine. And we could buy additional lysine to meet our lysine requirement. The question is, how much lysine should we buy? Should we buy it up to here, here, or here? And the answer is here. If I can only buy lysine, I buy it to that point. And the reason I buy it to that point is because if I feed more than this, it's not going to be used to store more water because threonine becomes my limiting amino acid. So threonine is our second limiting amino acid. If I could go to the store and buy 2 amino acids, one being lysine and one being threonine, I would feed both lysine and threonine at this level, provided it was cheap enough and made sense. because what I'm doing now is I'm addressing all my amino acid deficiencies. And by doing that, that allows me to maximize performance. I'd only do this if performance, the value of my performance is greater than the cost of making this decision. The question is, what happens to this methionine up here and this excess methionine is metabolized? Okay, we're going to use it to synthesize other amino acids or use it as a source of energy. What we're not going to do is we're not going to deposit additional protein. The same thing would have happened here if I would have just bought all of this lysine without providing threonine. Is this extra, this red amount of lysine would be metabolized. The valine would also be metabolized and used as a source of energy or something like that. But only when I provide them at their proper levels, all of them, is performance optimized. Okay? So, y'all have a good day. Stay out of trouble.